Bismillahirrahmanirrahim. Greetings. In the first two video lectures, I discussed the subject of function and emphasized the importance of the word each that was imposed on the elements of the first set, that we will later on call it domain, and not on the second set. And that gave rise to possibilities and cases. Then I used a schematic diagram or arrow diagrams to further enhance the conceptual understanding of you. And now in this video I'm going to add to those arrow diagrams graph, which is geometry, and also analytical formulas, and see how they can be related. Now, I have to also emphasize that these are for the, these visual aids are for the beginners to, again, enhance their conceptual understanding of the subject and to cement down the foundation. But as the knowledge increase and we become more mature in the knowledge of the subject, then the geometrical figures or any kind of visual aid should be set aside and bypassed, and we should proceed with the analytical approach. That's very important. All right, then let's start, shall we? I will zoom it up and go back to that. Now stay out of your sight. Now here, look at the schematic diagram or arrow diagram. Two elements from the set of first set that we call it domain later on. We call this one domain and this one range, but domain and range for the time being are just names, like calling somebody Nancy and let's say Debbie. They don't have maybe any meaning, but to just distinguish them from each other. And then later on, I will give a formal definition for the set of domain and for the set of range. But so for the time being, I do use the word domain and range, again, as a name to distinguish them. Now, as you can see, all the elements in the set domain have been used, so the first condition has been satisfied, and every two of them are hitting one element in the set of range. And as you see now from the diagram, from the graph, you can see that 2 to 1. You see, A is paired with B, and negative A is also paired with B. And also notice that the function is mapping real to real. As I draw and highlighted that the range is all real. So that means what? That means that all the elements of the range have not been used. Some are used in a sense, half of them are used and half of them are not used. So this kind of function, which I wrote y equal to x squared, you are familiar with that problem. This kind of function are called into functions or into mapping. Mapping is another name for function, because when you map, for example, a sphere into a 2D, there is one-to-one correspondence. So that is the word map means one-to-one correspondence. So this, as you can see, the domain and range of this function, both are real. Now this is the same function. You see y equal to x squared, y equal to x squared, with one difference, that they both have the domain of real numbers, but the range, second set, the range of this function is the set of all real numbers including 0. And I have highlighted with the bar with the orange color. So the domain is all real, and the range is all real number, positive real numbers and 0. And in this case, look what happens, the difference. This kind of function is called onto. We can call it onto mapping. Another name for that is surjective. So again, how important it is the domain and range to recognize, even though both of them are graph of what? A problem. Both of them are graph of problem. Okay? Let's go to the next if we may. Now in this next diagram, as you notice, the schematic diagram, all the elements of the domain are used, so the first condition is passed, and they are mapped or paired, well, uniquely, that also passed, but only one element, the range has only one element. You see that set of 7, that is 7. This number is 7, and as I wrote, y equal to 7. So the range is only what? Is only 1 point, the range. But the domain is all real numbers. You see that? The whole real numbers. All real. Now, this is called onto mapping, because all the elements in the range, which is only one single element, have been used. There is nothing left. So this is called onto mapping, or what? Or surjective. Now, the very same equation, y equal to 7, is we are investigating, but in this case, the function is mapping real to real. Not real to 7 only, real to 7 to real, which means all the range is the entire real numbers, but only 1 point of that, one element of that set has been used, has been mapped with them. So this is called an into mapping, or you can call it not onto, or not surjective. All right, you clear with that? Let's go to next, if we may. Now, in this schematic diagram that you're already familiar with, as you can see, the function, I didn't write, I could maybe write a way to write it. The function is mapping real to real. In this case, the function is mapping real to real. You see that? So the range is entire real number, as I have highlighted with a green color. You can see that. And the domain is all entire real number. And the analytical formula for that is y equals a to the x, like 10 to the x, or 2 to the x, or e to the x, or whatever you can. So I put it in general, I put a to the x. That is the graph of that, is called exponential function. And this, the function is from real to real, so we call this one what? We call this one into, as you can see here. There is an element in the range that has not been used. As a matter of fact, more than almost half of them has not been used. Only half of the elements in the range have been used in this graph. So this is called an into mapping. All right? Now, in contrast to this graph, you see that exactly same. Again, y equals to a to the x is the function, but in this time, the domain is against this entire set of real numbers, but the range of that is a positive real numbers. You see that? So the domain is all real number, and the range is positive real number, and the entire elements in the set of the range have been paired with elements from the set of domain. They have been used, there is nothing left here. Here there were quite many left, in fact half of them were left, more than half. And here nothing left, so this is called an onto mapping or surjective. Now, then let me go also one that I covered last time about one-to-one correspondence, which has a special interest we have on that. Let me see if I have that one to go over that. Hopefully you are comfortable with this one. No, yes I do, fortunately. It's over next to me. Now, this is a schematic diagram of a one-to-one correspondence, which means all the elements in the set of domain has been used. Of course, naturally they should be used, and all the elements in the set of range have been used. Do you see that? So this is called one-to-one, and two of them are not hitting one element here that does not violate the definition of function, but is no longer one-to-one. So this one we call one-to-one correspondence. And this kind of function, the inverse of that, which means we change the range into domain and domain into range to exchange the two sets, as I have done here, this is called the inverse of that. Like exponential function, when we go to the log, we will see that they are inverse of each other, and we study them in more detail. Okay, then let me now zoom in, and so that you can see me. Okay, I would like to repeat myself that these visual aids are for the beginners. And as you become more mature in the knowledge of the subject, you have to train your mind to be effective and to be bypassing the geometrical and visual aids and think about analytical approach. All right. Now, what I will also would like to say, maybe as a preliminary for the videos to come, I go over the definition one more time. He said that definition of function was for each element is the rule of correspondence between two sets. So we are talking two sets, such that each element from the first set is paired with an element from the second set. So the word pair motivates the idea that we ask ourselves, okay, can we define function from the point of order pair, from the point of set of order pairs, which will be kind of paraphrasing of the same definition but in a different way of looking at it. And that is what we are going to investigate. And again, I repeat myself, the motivation was that we use the word pair. Each element from the first set is paired with an element from the second set. So that gives us the idea that, okay, can we go ahead and define function from the point of what? From the point of order pair, set of order pair, from that point of view. So that will be for the videos to come, and also I will be going more into graph of one-to-one and onto functions like exponential and log functions and correspond them together, and very nice thing comes out of it. Okay, then again I have the habit of giving an army salute to all my audience and wish you all prosperity, and please stay safe. Thank you for watching. So long.